Hello, ladies and gentlemen. We're talking about section 3.2 today, talking about parallel lines and transversals. So we know about parallel lines and transversals separately, and now we're going to look at them together. So these lines are parallel. We know this because of the arrows, and we have our transversal, which is cutting through both lines. So we know about corresponding angles, alternate interiors, alternate exteriors, and consecutive or same side interiors. Well, corresponding angles are angles in the corresponding or same position. So both of these angles are in the top right of each little intersection. So in this case, anytime you have two parallel lines that are cut by a transversal, the corresponding angles are always congruent. The measures are always equal to each other. This is our postulate 15, corresponding angles postulate. It's a postulate because it is accepted as fact and assumed to be true. There is no proof for it, unlike a theorem. So, again, anytime two parallel lines are cut by a transversal, any pair of corresponding angles are congruent. So, for example 1, the measure of 3 of the numbered angles is 120. Identify the angles and explain your reasoning. Well, if these two lines are parallel, which is given by these arrows, we know corresponding angles are congruent. So if 120 is congruent, angle 5 must be congruent to it. I'm sorry, if 120 is 120, angle 5 should be 120. So angle 5 is congruent. It's 120 degrees. We know that because corresponding angles postulate. We also know that angle 4 is 120 because these are vertical angles. So we know that angle 4 is 120 degrees, and that's our vertical angles theorem, which says that vertical angles are equal. And then lastly, if this is 120, we know angle 8 is 120 because these are corresponding angles, and also because these are vertical, so either way you look at it. I'm going to say that angle 8 is 120 because it's corresponding angles postulate with angle 4. Angle 4. Or it's corresponding to angle 4. Either way would be fine. So again, anytime two lines that are parallel are cut by a transversal, corresponding angles are congruent. The three other angle pairs we talked about, alternate interiors, alternate exteriors, and consecutive or same side interiors, also have special relationships. Alternate interiors, the theorem 3.1 says that they are going to be congruent. So alternate interior angles are always congruent, just like corresponding angles. Since it's a theorem, there is a proof, and the proof is located as example 3 on page 156 if you'd like to take a look at it. Alternate exteriors are also congruent, just like corresponding angles. Again, there's a proof on page 159, example 37. And lastly, theorem 3.3, our consecutive interior angles theorem. They're not congruent like the rest of them, they're supplementary. So in this picture over here, these lines are parallel. Angle 3 and angle 5 are going to be supplementary because they're same side interior angles. And again, there's a proof of this as example 41 on page 159. And I would take a look at it if you're curious as to why this is true and you're curious as to see the proof regarding it. Okay? So again, alternate interior angles theorem, alternate exterior angles theorem, both are congruent, and consecutive interior angles theorem, which says they are supplementary. So let's look at an example. Here we're asked to find the value of x. Well, let's examine and see if there's a relationship between the 115 that's given and our expression with x. Well, they're not corresponding because one's in the top left and one's in the top right. They're not alternate interiors because this is on the outside. And they're not alternate exteriors because this is on the inside. They're also not consecutive interiors because one's on this side and one's on this side of our transversal, I'll call it T, so they are alternate of some sort. So what we should do is see if we can make a relationship happen using vertical angles or linear pairs. So we have two options, and I'll show you both of them. Both of them will work. So option 1. 115 and angle 4 are vertical, so angle 4 is also 115. These two angle pairs are consecutive interiors. They're both on the same side of our transversal and on the interior of our parallel lines. So they're supplementary. So x plus 5 plus 115 should equal 180. And if we combine like terms, this is x plus 120 equals 180. So x is going to equal 60 when we subtract 120 from both sides. That's option 1. Option 2, instead of using vertical angles, let's use a linear pair and see if that helps us as well, which it will, because you know I wouldn't go through it possibly otherwise, unless I'm pointing out a mistake. But if this is 115, these two form a linear pair, so they're going to be supplementary. So this will be 65, because 65 plus 115 gives you 180, so they are supplementary. So if I look at my x plus 5 and this 65, they're corresponding. They're both in the top right part of the two intersections, so they're equal. So x plus 5 equals 65, and if I subtract 5 from both sides, the 5's cancel and x is 60, so either way you get the same answer. So if you see that some sort of relationship isn't possible now, use linear pairs or vertical angles to see if you can make one like we did here. And let's look at a couple more on this page. So if the measure of angle 1 for number 1 is 105, we're going to find the measure of angles 4, 5, and 8. Tell which postulate or theorem you use in each case. So let's start with, this is number 1. We'll find the measure of angle 4, 5, and 8. So angle 4, well we know angle 1 is 105. We're going to use that because they give it to us. And angle 1 and angle 4, we want to identify what type of relationship do they have. Well, they're across from each other in an X formation, two lines intersecting, so they're vertical angles. They're going to be congruent, so they're both 105. So it's 105 degrees, that's our vertical angles theorem. For angle 5, well, if I go back to angle 1 and angle 5 are corresponding. They're both in the top left, so they're equal. So this is also 105 degrees because of the corresponding angles postulate. Again, we can use that because our two lines are parallel. We see that with the arrows. And lastly, angle 8. Well, angle 5 and angle 8 are going to be vertical angles, or you can say that angle 4 and 8 corresponding. This time I use the vertical angles. So either way, it's 105 degrees. Now I'll say vertical angles theorem. And that's with regard to angle 5. So that's part 1. We found the measure of angles 4, 5, and 8. I'm going to erase this, so if you need to pause it to write it down, go ahead and do that. Otherwise, I'm going to move on to example 2. All right, so moving on to example 2. The measure of angle 3 is 68. Let me label that. And the measure of angle 8 is 2x plus 4. What's the value of x? Show your steps. It doesn't say explain or justify or prove. It just says show your steps. Well, in this case, these don't form any type of relationship that we've talked about. They're on the same side, so they're consecutive, but they're on the exterior. Now, I will tell you this, the same side exteriors or consecutive exteriors are just like consecutive interiors. They're supplementary. But let's look at why. Well, if I use vertical angles here, angle 2 is also 68 degrees, and angle 5 is also going to be, let me put a little arrow here, 2x plus 4 degrees. And since they're also consecutive interiors, they are supplementary. So anytime you have consecutive exteriors, they're all going to be supplementary because using vertical angles, they're really the same thing as consecutive interior angles. So I'm going to say these are supplementary. So 68 degrees plus 2x plus 4 degrees will equal 180. And if I combine like terms, this is 2x plus 72 equals 180. Subtracting 72 from both sides, 2x equals 108. Is that right? 108, yep. And so x equals 54. Again, feel free to pause as needed. I'll go on to 2 more slides and we will be finished for today. So let's look at a proof. All right, prove that if 2 parallel lines are cut by a transversal, then pairs of alternate interior angles are congruent. So we're actually going to go through the proof of the alternate interior angles theorem. Since we're going to try and prove that, we cannot use that as a reason since we're trying to prove it. Okay? So we're given that the lines are parallel, and we want to prove that angle 1 is congruent to angle 2. Alternate interiors are congruent. So we're going to use our given information at some point here. Let's start with that fact. And since they're parallel, we know that certain angles are congruent if they're parallel. Let's start by maybe possibly using our postulate. Angle 1 is congruent to angle 3. I think that was the first one in here. Yes. And that's because of the corresponding angles postulate. So I know that fact. Then I need to somehow show that angles 1 and 2 are congruent. Well, I know that 1 and 3 are congruent. I also know that 2 and 3 are congruent because they're vertical angles. And since 1 is congruent to 3 and 2 is congruent to 3, they are congruent to each other by the transitive or substitution property. So any of these theorems or postulates about these special angle pairs we can use in proofs to prove that certain angles are congruent or supplementary or what have you. This is a very short, brief proof of the alternate interior angles theorem, just for your viewing pleasure. And 3 final examples that we talked about in class. I'll go through all 3 of them very briefly. So for number 1, these lines are parallel. We want to first identify the relationship between the 2 pieces of information that are given. So 75 and 5x minus 10. Well, they're both on the interior and they're on the same side of our transversals. So they're consecutive interiors, which are supplementary. So 5x minus 10 plus 75 should equal 180. Combining like terms, 5x plus 65 equals 180. Subtracting 65 from both sides, 5x equals 115. And dividing both sides by 5, x equals 23. So we solve for x. We don't have to plug it back in because it's just asking for x. For number 2, we want to again identify the relationship. Well, they're on the same side, but they're not interiors, and they're not both exteriors, so we can't use that. But they are corresponding. This is in the top left of the intersection. This is in the top left. So since they're corresponding, they are congruent. So we set them equal to each other, and then divide by 3. These cancel, so x is 40. For number 3, we have 2 options. I'm going to take the vertical angles option. So these do not form any of the 4 special relationships. So I need to make one happen. So if these are vertical, I'll say this is 105. And now I have a pair of consecutive interiors. So x minus 2 plus 105 equals 180. Combining like terms, negative 2 plus 105 is 103. So that should be plus 103. Equals 180, and subtracting 103 from both sides, x is 77. That concludes your 3.2 notes. Hopefully these are helpful, and hopefully you feel more comfortable using parallel lines cut by a transversal.